proposed start type 6 differential equations in slope fields. That leaves just type 7. We have done a couple of these problems. 2015 number 4 we have done, and 2017 number 4 we have done. Those were in the low scoring free response questions. We also did, for the test on this unit, we did a lot of the free response questions. So I expect this to be pretty familiar, some of these to be more familiar than others. But let's just kind of go through it. And then next week, we're going to pick up with finishing these off and then type 7. And then we are done the 7 types of free response questions. Okay, so focus topic 6 is differential equations in slope fields. I do not think we're going to be creating a slope field this year. I can't imagine how you could do that on a Google Doc. But you know, it could always surprise me, which you guys like making them, so that would be nice, but I don't think we're going to see it. What you should be able to do is to find the general solution of a differential equation using the method of separation of variables. Okay, so if I go down here, the 5 points, how they distribute them. The first point on any of these free response questions is separating the variables. So putting the x's on one side, the y's on the other, and then the dx and dy with, you know, with its respective variable. You get 1 point for finding the antiderivative. So you integrate, make sure that any constants you leave with the x, and integration here, we have a plus c with the x side only. At that point, if there's an initial condition, we need to plug it in immediately. Don't manipulate the equation, just plug in the initial condition to find your plus c. And you get 1 point for including the constant of integration and using the initial condition. That is for writing plus c on the paper and substituting in the initial condition to find what that c is. And then the last point is the answer point. And this includes the algebra and the arithmetic, like the moving stuff around. So if you think about how this breakdown is, we got 1, 2, 3, 4, 5, right? So if the algebra, and that usually tends to be the hardest part of these problems, it's only 1 point, right? So get through the first 4, at the very least always separate it and get that easy point. So let me go back up to what we were talking about before. Okay, so then what else these equations will ask you to do is find a particular solution using an initial condition to evaluate the constant of integration. This is where we see an initial value, and I'm going to look at your homework one real quick before we go. A new concept that's been tested since 2016 is to determine the domain restrictions of the solution of a differential equation. So this is where you have to look at, like, let's say your initial condition is 2, -3, and you had a square root problem. So what you have to pay attention to is that if you rewrite all this algebra, you got to remember that the answer here would be negative because the initial condition was negative. Okay, understand that proposed solutions to a differential equation is a function and not a number. And if it and its derivatives are substituted into the given differential equation, the resulting equation is true. This may be part of the problem even if solving the differential is not required. There is some growth and decay, typically not in these problems. We see a lot of that more with a multiple choice, and of course we don't have that this year. I don't think you're going to draw a slope field by hand, not that that's hard for you. Sketch a particular solution on a given slope field. This is where you got to like plot the initial condition, kind of sketch through what you think the graph will look like. Interpreting a slope field and using the given derivative to analyze a function, such as finding extreme values. Okay. So I'm going to quickly just look through the problems I assigned for homework. Sorry that this is written on already. We were doing it this morning in Zoom for those that didn't attend. Okay, so this landfill problem, they give an initial condition of 1,400 tons of solid waste. So this is 0, 1,400, right? The increasing function W models the total amount of solid waste stored at the landfill. Planners estimate that W will satisfy the differential equation dW dt equals 1/25 W minus 300 for the next 20 years. Okay, so when I see these problems, I immediately look at my variables, right? I have a Y value over here, and there's no X value in this equation. And so when you are asked to start substituting in, remember that there's no place for t. All right, so part A says, use the tangent line of the graph of w at t equals 0. All right, so we have that initial point. What we need to find is dw dt at t equals 0, right? And so this is where you're actually going to use that initial 1400 to figure out what that is. Finding the second derivative, make sure that when you take the derivative of this, after you take the derivative of w, there's a dwt, and then you substitute in. And then it asks about an overestimate or an underestimate. Because we're talking about the second derivative, then we're looking at concavity, right? Would the tangent line lie below the graph, or would it lie above the graph? And so if it's concave up, it's one way, and if it's concave down, it's the other. And then finding the particular solution, and this is where we get those 5 points we talked about on the first problem. All right, so give that one a go and see how it goes. The second problem I assigned was the baby bird problem. We talked about it this morning. I think we may or may not have done this when we took the test. It seems familiar, but for me, they always seem familiar because we do them every year. So take a look at it. I don't want to kind of analyze that one. I want you guys, after you do the first one, to kind of look at that and see where you're at, and then we'll go from there. I hope you all have a lovely weekend. I decided to move all of your due dates to Monday at 9. I know that you have had a lot of work over the past few days, and I would love, for you to just put calculus aside for today and concentrate it maybe over the weekend so that you're ready to go by Monday. I hope you all have a great weekend. I miss you and I love you. Take care of yourselves.